absolute maximums and absolute minimums. And this is sort of our intro into graph sketching. So we're about to really dive into what a derivative tells us about a graph and what a second derivative tells us about a graph. And just by looking at those derivatives, we're going to be able to picture in our heads what this function looks like without even having a picture of it. And it's so cool. So this is just an intro to it. We're just going to start by talking about maxes and mins, and we'll eventually take it a little bit further, probably tomorrow. Do I see you guys tomorrow? Yeah, I do. Maybe tomorrow. All right. So let's talk about the difference between absolute extrema and relative extrema. So absolute maxes and mins can take place at endpoints on an interval, or it can take place throughout the interval. Relative max and mins can only take place inside the interval. They cannot take place on the endpoint. So here, if I look at this example I have here, this is the interval a to e, if we're talking about x values, right? So we could have absolute maximums or absolute minimums at those endpoints, and I actually do. The absolute minimum on this interval takes place at a. The absolute maximum doesn't take place at one of the endpoints, and that's okay. The absolute maximum takes place at d, and I'm just going to say this, I think it's common sense. When I talk about absolute max and mins, I'm talking about the absolute lowest point on that interval and the absolute highest point on that interval. Relative max and mins are clear maximums or minimums, but they're not as high or as low as the absolute. So I'll say it again. Relative max and mins can take place within an interval, but they cannot take place at endpoints. Absolute max and mins can take place in the interval and also at the endpoints. So I'll say it again because you guys love to forget this. Absolute max and mins can take place at the endpoints. And I think part of the reason that you guys forget that is because in the end, absolute max and mins aren't as important as relatives, but we need to remember this. All right, so I'm probably going to say it about 12 more times. Why don't I just say it again right now? Absolute max and mins can take place at the endpoints. All right. So, oh, look at this. I even wrote it out here for you. So it's something I really want you guys to understand. So what do you notice about the slope of a tangent line, aka the derivative, at relative max and mins? Well, hold on. This is a relative max. So what do I know about the slope of the tangent line right there? The slope of the tangent line is 0 at that point. And at this relative min, the slope of the tangent line is 0. And same thing here at this max. The slope of the tangent line is 0. So the other day, I kind of had you guys just do a random assignment on critical points. And you're probably like, what the heck is a critical point? Well, a critical point is where the derivative is either undefined or equal to 0. Wait. Equal to 0? So a critical point tells me where my max and mins occur. Oh my gosh, that is so cool. If I set a derivative equal to 0, I'm going to be able to know where on the original function there's a relative max or min. That is super cool. All right, so critical points give me the x values of max and mins, relative max and mins. Very good to know. Okay, I'm going to remember that. So, example, find the absolute minimum and absolute maximum of f of x equals 2x cubed plus 3x squared minus 12x plus 4. So, we want to find the absolute min and the absolute max. Okay, so in order to do that, I need to know, A, what the function value is at x equals 4, x equals 2. I'm sorry, negative 4, and x equals positive 2. And I also need to know the location of my relative max and mins within this interval. Because a relative max or a relative min could still be the absolute max or min. So my first move here is to find my critical points. So let's do that. So f prime of x is equal to 6x squared minus 6x minus 12 I want to know, where is the slope of the tangent line equal to 0? I'm going to take out a 6. X minus 2, x plus 1. Good old factoring from Algebra 1 never goes away. So I have either a relative min or a relative max possibly at, and I say possibly because we'll talk more about that at a later date, at 2 and negative 1. So the first thing I do is I check to see if those points are on the interval in question, because if they're not, I don't even need to check them. But they both are on the interval, right? 2 happens to be one of the endpoints, and negative 1 is on the interval. So I'm going to have to check both of those. That's okay. So let's now evaluate the function at the critical points and the endpoints. All right, so let's do that. So I need to find f of negative 4. I need to find f of negative 1 and f of 2. Right? I don't know why my answer key is oh my gosh, did I screw up my derivative? I did screw up my derivative. How many of you were screaming at the screen? Because I'm like looking at my answer key, I'm like, why is negative 2 an option? All right, so we got to fix this, guys, and I'm not going back and starting the video over. It is 8:38 at night, and you guys can just deal with my mistake. All right, so guys, when I found the derivative, I know you guys are just saying, yeah, Mrs. Bucko, you're an idiot, is 6x squared plus 6x minus 12. Oh my goodness, so that screwed up my factoring. So this would be plus, so then this would be plus, and this one would be minus. Oh my goodness, we have so much more extra fun stuff to check. I was going to say, that was weird of me to make the endpoint match up with one of my relative max or mins. All right, so I apologize, guys. You can bear with me. All right, so this is really x equals negative 2 and x equals positive 1. All right, so we have a lot of checking to do. So we have to check both endpoints and both of these x values because they both fall on the interval. So this is negative 2, f of 1, and f of 2. So the absolute max or min can take place at the endpoints or at the relative max and min. So I've got to check all of them. And remember, they're not always going to ask for absolutes, but sometimes it happens, so we need to be able to do it. So f of negative 4, I'm plugging into the original function, guys, right? I'm talking about the values on f, not on f prime. So I'm just going to write some of this out here for us. Plus 3 times 16. Remember, guys, whenever you square a negative number, it's positive. And you would not have access to a calculator for this, so we would have to figure these out, but I'll tell you right now, that's equal to negative 28. F of negative 2 would be 2 times negative 8 plus 12 plus 24 plus 4. That's equal to 24. F of 1. See, I should look down at my answer key more. I have the answers in front of me, and I would have caught my mistake earlier if I just looked down at it. I just have too much fun doing the problems. All right, plugging in 1 is super easy. So this is 2 plus 3 minus 12 plus 4. And what's that? Negative 3. And then f of 2 would be 2 times 8 plus 12 minus 24 plus 4. And that would be 8. So once I evaluate the function at the critical points, I should have the critical points on the interval. Because let's say we had gotten a critical point was 5. Do I need to evaluate that? Absolutely not, because it's not on the interval in question. All right. So once we've done that, we now need to identify the absolute max and absolute min. All right, so let's see. Negative 28 looks like it's my lowest. So this one looks like it's my absolute min. And 24 is my highest. So that's my absolute max. And I'm going to write a nice little sentence out just because I want the person looking at my work to know that I understand what's going on. So I'm going to say we have an absolute maximum of 24 at x equals negative 2. And we have an absolute minimum of, what was it, negative 28 at x equals negative 4. So this was an example where our absolute minimum occurred at one of the endpoints, but the absolute maximum occurred in the middle of the interval. Both of them are acceptable. There was something I just wanted to say. I don't remember. Maybe it'll come back to me. Did I really just do that? All right. So clearly it's not my night tonight, guys. There was something that was like really important that came into my, oh yeah. All right. So when I say I have an absolute maximum of 24, that's the y value, right? That was the function. We evaluated the function at this x value to get this y value. So if a function or if a question says to you like, what's the maximum value on this interval? They're looking for the y value. If they say to you, where does the maximum occur? They're looking for the x value. So you really have to pay attention to the wording of the question. So if they say, what is the maximum value? They're looking for the actual value, the y value. But if they just say, where does the maximum occur? Well, then they're just looking for the x value. And we're going to get to a point pretty soon where we don't need to actually plug in to see what the highest or lowest point is. We're going to be able to figure out maxes and mins an easier way. And we would just have to find the x values. So very important to pay attention to the wording. One last point I want to just reiterate is when we were checking these critical points and the endpoints, we were plugging into the original function because we were looking for the absolute min and the absolute max on the original function. Okay, let's try another one. So find the absolute min and max of, okay, it's the same exact function. Is this just a repeat question? My goodness, Mrs. Bucko. Are you really losing it? No, I'm not really losing it. What did I do? I changed the interval. Okay, so we knew that I had x equals negative 2 and x equals 1 as my critical points. And I also need to check x equals 0 and x equals 2 because those are the endpoints on my interval. But what is not part of the checking or what's not on my list is this guy anymore, right? I don't care about what's happening at x equals negative 2 because it's not on the interval in question. Okay, so that's like a mistake that you guys love to make is like you get your critical points and you test them. Critical point, I test it, I plug it in. Critical point, I plug it in. Please, please, please make sure the critical points that you find are on the interval in question. A, you're creating more work for yourself. And B, if we looked over here, negative 2 ended up being our max. And wait a second, if you had told me over here the maximum occurs at negative 2, no, it doesn't. It's not on the interval. Okay, so the only thing I have to check right now is f of 0. I love when I have to check 0 because it's always so easy to plug in. F of 1, which I think I found on the other page, didn't I? Yep, it was negative 3. So I'll put that in. And f of 2, which we had on the other page, which was 8, if I'm correct. Let me look. Yep, it was. So f of 0 is 4. I'm just plugging into the original function. So now I'm very easily able to see this is my absolute min on this interval, and this is my absolute max on this interval. So negative 4 was the endpoint on the other one, and negative 2. So we have completely different answers, guys, because the interval changed. So here, the function has, on this interval, we have an absolute max of 8 at x equals 2, and we have an absolute min of negative 3 at x equals 1. Okay. So you try one. So go ahead. You guys try. When you're done, you can check your answer against mine. So hit pause right now. Well, you probably hit pause already. Anyways, hit pause, go ahead and try it, and then unpause to check your answer against mine. I'll do it real quick. You guys can just fast forward through my work when you're checking. So I've got to do f of 0, which is negative 3. I've got to do f of 2 and f of 4. So f of 2 is 8 minus 12 minus 3. What's that? Negative 7. And f of 4 is 64 minus 48 minus 3, getting 13. All right, so this is very clearly my minimum value, and this is very clearly my maximum value. So I have absolute max of 13 at x equals 4, and I have an absolute min of negative 7 at x equals 2. All right, hopefully you guys agree with me on that one. And it looks like we have 2 more to try together. Actually, I think I'm probably going to do one with you, and I'll let you try one on your own. All right, so this one is not annoying, but again, it's just making sure that you still remember your derivative rules. So first thing I'm going to do is find f prime of x, but I'm going to actually, what I'm going to do is I'm going to rewrite f of x so it's easier to find the derivative. So f of x is equal to 4 times x squared plus 2 to the negative 1. This is the chain rule. All right, f prime of x is equal to negative 4 times x squared plus 2 to the negative 2 times the derivative of the inside is 2x. So f prime of x is actually negative 8x over x squared plus 2 quantity squared. All right, I've got to set this equal to 0. So the denominator, so I'll just show you the algebra since I know you all have wonderful algebra skills, but I'll still just show it to you. If I was going to set this equal to 0, the first thing I'm going to do is multiply by the denominator, so that's going to go away. So the only critical point is where negative 8x is equal to 0, which is at 0. And wait a second, I look at my interval, it's not even on there. So I just did all of this work for nothing. Oh well, I still need to find f of 1 and I need to find f of 2. So one of them is going to be the max and one of them is going to be the min. It's that easy. So f of 1 looks like it's coming out to 4/3. And f of 2 is coming out to 2/3, 4/6, right? Which is 2/3. So this would be my max. This would be my min. So I'll say absolute max of 4/3 at x equals 1. And I have an absolute min of 2/3 at x equals, where am I, 2? Easy peasy. One more together, and then I'll let you guys try some bookwork or whatever I feel like assigning you, because clearly I haven't thought much about it. Give me a break. We are dealing with COVID in this house, and basically I'm just cleaning nonstop, making sure that no germs get spread. So I guess I haven't really been thinking about my AP Calculus videos. We'll let it slide this week. All right, find the absolute max and min. So once again, I'm going to start by finding the derivative. So that's 4x cubed minus 4x. So the critical points are when the derivative is equal to 0. I'm going to take out a 4x. I'm going to be left with x squared minus 1. So this is 4x. This is difference of 2 squares. I know you all remember that from Algebra 2. So I have x is equal to 0, x is equal to 1, and x is equal to negative 1. So what I'm going to check now, and I hope that some of them are not on the interval because I don't want to plug all these in, from in between 0 and 2. So that's one of the endpoints. That's on the interval. This is not. So I have to find f of 0, f of 1, and f of 2. F of 0 is 3. F of 1 is 1 minus 2 plus 3 is 2. Oh, I'm going ahead. At least you know it's going to be either the max or the min. Clearly the min if 3 is here. So this is going to be 16 minus 8 plus 3 is equal to 11. So, okay, so this one's going to be my min, and this one's going to be my max. And I might as well write it out nicely since I always yell at you guys to write things nicely, so I need to do it too. So we have an absolute max of 11 at x equals 2. And we have an absolute min of 2 at x equals 1. Okay. As you can see here, I just wrote one thing, some final thoughts, and I already said this to you guys multiple times. Be careful with the wording of the questions. If it asks for a maximum or a minimum value, it's looking for the y value. So this kind of comes up in multiple choice sometimes, where it's like, what's the maximum value of this function? And you're like, huh? What are you talking about? And then sometimes you just find an x value. No, it's asking for the maximum value, so you actually have to find like what is the function value at that point, which is the y value. If the question asks where the max or min occurs, then we're looking for the x value. And I might as well just say it one more time because I know some of you are going to forget. Absolute maxes and mins can occur at the endpoints. Relative max and mins can only occur inside the interval. All right, guys, I apologize that my video was a little crazy tonight, but thank you for bearing with me, and check out Canvas for what I want you to do next. I will talk to you soon.